Density is an important property of all materials. In this experiment, we'll use density to demonstrate the utility of plotting data. Density is defined as mass over volume. Typically, we use units of grams per milliliter, but any combination of mass and volume units is valid. We can find the density of a material by measuring both the mass and volume of a sample of it. In this experiment, we will measure the mass and volume of 4 standard sodium chloride solutions and an unknown solution. Then we'll calculate the density of each. For each solution, we'll first measure the volume, exactly 10 milliliters with a volumetric pipette. Then we'll measure the mass with a balance, and we'll do both of those things 3 times for accuracy and calculate the average. Then we can calculate the density. If you've forgotten, the average can be found by calculating the sum of the values and dividing it by the number of values. Once we've done all this, we can generate a plot with the 4 standard solutions, which will look like this. This plot uses made-up numbers, but the %x here stands for the solute, which in our case will be sodium chloride. On the y-axis, we've plotted density, and on the x-axis, the % of the solute in each solution. The line formed from the points gives us a visual representation of the relationship between these 2 variables. The equation of the line mathematically represents that relationship. For this equation, y corresponds to the density, and x corresponds to the % solute. This plot can be referred to as a standard curve, since it's composed of points that we already knew both variables for. The standard curve allows us to figure out variables that we can't measure directly. I know what the density of my unknown solution is, since I can measure both the mass and the volume of it. However, I don't know what the %x is in my unknown solution, since I can't measure that directly. Using the equation of the standard curve, I can plug in the y value for my unknown solution as the density, and simply solve for x, the thing I don't know. In this way, I'll be able to determine the % solute in my unknown solution.
This is a volumetric pipette. This one is calibrated to deliver exactly 10 milliliters of liquid. The tip is submerged into the liquid to be pipetted. The enlarged area is a reservoir for liquid, and the calibration mark shows which level corresponds to 10 milliliters. Air is pulled through the top to allow the liquid to be drawn into the pipette. Volumetric pipettes can be tricky to operate, so let's demonstrate how one is used. A pipette valve is used to draw air out of the pipette and allow liquid to flow up. One hand is used to hold the bulb, and the other holds the pipette. The pipette can be held with either the thumb or the forefinger over the opening. The end of the pipette is placed in some liquid, not touching the bottom of the container. Then the pipette bulb is compressed and placed over the opening. Releasing the bulb draws liquid into the pipette. If the liquid does not reach the calibration mark, the bulb is removed, and in one swift movement, a finger is placed over the opening to prevent drainage. Once the liquid is above the calibration mark, the bulb is removed. Now the pipette is removed from the liquid, and the excess is slowly dispensed by partially removing the finger over the opening. The final liquid level should align with the calibration mark. It may take a few tries to get the correct volume, but you'll improve with practice. Once the calibration mark is reached, the pipette is held over a new container, and the finger is removed to dispense the liquid. Gravity will drain the pipette. Once it is done, there will be some liquid left in the tip, and that's okay. It's calibrated to account for that. We can touch the tip to the edge of the container to remove the last drop, but what's left in there is alright. In this experiment, you'll pair up with a partner to generate a standard curve. Between the 2 of you, you'll complete the following process for 4 standard solutions, and you'll each measure the unknown solution as well. We'll demonstrate with 4% sodium chloride. I'll start by pouring some into a beaker to pipette from. First, I'll pull up some of the solution into the pipette and just shake it around a little bit to rinse it out before letting it drain into a waste beaker. After tearing a balance and measuring the mass of my beaker, I'll pipette 10 milliliters of the solution into the beaker and weigh it again. Then I'll add another 10 milliliters, weigh again, and repeat the process once more. With a little subtraction, I can find the mass of each portion of solution. This process is repeated for the 8% solution, and my partner covers the 12% and 16%, and we'll each measure the unknown solution in the same manner.
Plotting is used to give us a visual representation of our data so that we can understand the relationship between variables. Here you can see I've typed some of my data into Microsoft Excel. Each variable has its own column. In column A, I put the percent solute for 4 different solutions. And in column B, I've put the corresponding density for each of those solutions. These are all made up numbers, so I wasn't specific about the solute, but the solute that you'll be using in this experiment is sodium chloride. To generate a plot, I'll click and drag to select my entire data range. Then I'll click Insert up in the ribbon, and in this section of charts, I'll click this one that looks just like a scatter plot, click this Normal Scatter. In chemistry, we're almost always going to use this type of plot. Here we see the default plot that Excel generated. Let me just make sure that it's put the x-axis on the x-axis. So I want percent solute on the x, that's in the range of 10 to 40, and here I see 10 to 40. So it looks like it plotted the data correctly. If it didn't, I could always right-click on the plot, select Data. Here's my data series, and if I click Edit here, I can manually select the X and Y ranges. If the plot is selected in Excel, you should see this Chart Design tab up in the ribbon. If you click on that, you'll see this Add Chart Element button. I always want to have axis titles for both the horizontal and the vertical axes. And I'll also often want a trend line, usually linear. I can edit the labels on the plot by clicking on them. For axis labels, I want to make sure to include the units. The title should be in the format of Y variable versus X variable. There's one more thing to add to this plot. The trend line gives me a visual representation of the relationship between these two variables, but I want a mathematical relationship. So let's figure out the equation of this line. Right-click on the trend line and click Format Trend Line, and this sidebar should show up. And when these 3 bars are selected, there's 2 checkboxes here. One's for display equation on chart, one is for displayed R² value on chart. There's my equation that gives the precise relationship between the 2 variables, and the R² value gives me an idea of how good that linear fit is, or in other words, how accurate that mathematical relationship is in expressing the true relationship. This plot is now complete and ready to turn in with a report, but let's make it look nicer first. The first thing I'll do is click on these grid lines back here. I'll just hit delete on my keyboard and do that for the other grid lines. And then I'll click on each piece of text and go up here in the Home tab of the ribbon and just make them darker, make them bold. I can change the font if I'd like. That all looks a little more legible. Now let's adjust the look of the lines. To change the axis lines, I'll click on the numbers of the axis, and in the Format sidebar, I can add some tick marks. And under the paint bucket, I can change the color to black, increase the width a little bit. I notice I had a lot of blank space on the Y dimension here. So let's adjust the bounds of this axis. If I click on the axis in the Format Axis sidebar, I can set the bounds of the axis. So for the minimum, I'm just going to change that to 1. If I click on the trend line, I can go to the paint bucket here, change that to black. I can even change the dash type. I'll click on just the points. And under the marker tab here, I can change the fill to black and the border to black. Now my plot is ready to share. I'll click on the whole thing and then right click and select copy. Then in Microsoft Word, I can simply paste my plot. There's a couple options for pasting. This first one allows me to still edit the individual elements within the plot, which can be nice, but it can mess up the formatting sometimes if you change the size. You can also paste as just a picture, and then it acts like any other image. You can also use Google Sheets to generate plots. Here I've got the same data, and I'll start the same way by highlighting the whole data range. This time I'll go to the Insert tab up here and click Chart. Here's the default plot Google Sheets generated, and it has helpfully automatically added my axes titles and the title for the whole plot. If the data wasn't where I wanted it to be, if the X and Y axes were flipped or something, I can click on this little ... up here and say Edit Chart. I get this sidebar, and I can change which data range is used for the X-axis and which is used for the Y. If it didn't automatically give me a scatter chart, I could select it under this chart type dropdown. The last thing to do here is add a trend line. And I can do that by going to the Customize section of this chart editor, clicking on the Series dropdown, and making sure I have my series selected. Can go and select trend line. And then under here for the label, use equation, and I'll check this Show R Squared option. If I wanted to change some of the formatting here, I can adjust the colors right here. And now my plot is ready to share. There are plenty of other programs that can be used to plot data. I recommend either the desktop version of Excel, that's the one that's downloaded to your computer, or the browser-based version of Google Sheets. Both of these programs have apps, either on iOS or Android, that aren't as full-featured, and I don't recommend using them. So if you have an iPad or something, maybe stick with the browser-based Google Sheets.